For topic 3, we're going to look at finding the asymptotes of hyperbola. So we're going to find the actual equations, and there's really two ways. And sometimes it's really nice if you can see kind of um, maybe the not as easy way so that you can appreciate the easier way. And so that's how I'm going to approach this today. I've lost my little glovey thing. You know what? We're just going to roll with it. Okay. So we have this idea of finding the asymptotes of hyperbola. There is an easier way. I want to show you this so you can kind of see how we go about getting these equations, and then you can see the like shortcut for it. Okay. So the steps to find the asymptotes. What we're going to do the hard way, and I don't mean to make this hard. I just want you to like understand how this really is, and then you can get the shortcut formula. We're going to make sure we have a standard form equation for an ellipse. We're going to replace the 1 with a 0. We're going to factor the left, which turns out to be the difference of perfect squares. And then we can solve and write this as linear equations of the form y equals mx plus b. I really do wonder where I put my little glovey thing because it helps with found it smudges. So this is, I'm just going to show you this for the first one. We're going to like really appreciate what we're doing, then I'll show you the shortcut for the second one. Okay, so first thing we need to do is we need to make sure our equation is in that like standard form where we have like the x or y term over something, the other term over something, and it all equal to 1. So let's divide everything by 72. You might recognize this equation because we worked with it earlier, okay? So this is really x squared over 9 minus y squared over 36 equals. Remember, really technically, we're going to say it equals 1 because that is what it equals. But for the sake of this, we then change that 1 to a 0, and that's going to allow us to factor and then solve. Okay, and again, I'm showing you this so you can kind of see where we get the really cool, easy thing in just a second. So we're then going to have x squared over 9 minus y squared over 36 equals 0. We can factor this as the difference of perfect squares. So we take the square root of the first term. So you can take the square root of the top and bottom separately. So we just get x over 3. And then you take the square root of the second term, which is going to be y over 6. You add, you subtract, and remember, we set this equal to 0, okay? And then you can take each of these and solve them individually. So we have x over 3 plus y over 6 equals 0. And we have x over 3 minus y over 6 equals 0. Well, what I would do at this point is I would get rid of the fraction. So I would look to see, hey, do I have an LCD? Well, I do. It's 6. So we can multiply each of these terms by 6. Well, when I do that, this 3 goes into this 6 twice, leaving me with 2x. This 6 goes into this 6 one time, leaving me with just y. And then 6 times 0 is 0. We want to write this as the equation of a line. So I would solve for y, and that gives me y equals negative 2x. Okay, that's cool. All right, we're going to do the same thing for the second equation. We've got an LCD of 6, so we multiply all of the terms by 6. First term, the 3 goes into the 6 twice, leaving me with 2x. Second term, the 6 goes into the 6 once, leaving me with minus y. And then we get 6 times 0 equals 0. Well, I want to solve for y, so in this case, I would just add y to both sides, and I get y equals positive 2x. So those would be the equations of the asymptotes that we had in that previous example, part A. So right here, these asymptotes that we have are really the equations y equals positive 2x and y equals negative 2x, okay? Now, there's a shortcut, and I hope you can appreciate the shortcut by seeing kind of like the longer work here. If you take, considering the center, so remember the center is going to be some value hk, all right? If you take y minus k and set it equal to plus or minus, notice we have the same equation here. We just have 1 plus 1 minus. If you, let me plug my computer in before it dies. There we go. You want to take the b and divide it by a. So remember, we have a squared and b squared. So a is the square root of a squared. B is the square root of b squared. If we take b over a and then multiply it by x minus h, we get the exact same thing. So let's do that with this example just to show that it really works. So in this case, we had a center at 0, 0. We have A was 3 and B was 6. Okay? So we're going to take y minus k, which is 0, over plus or minus b, which is 6, over a, which is 3, times x minus h, which is 0, and then we just simplify. So I get y equals plus or minus 2, and then x minus 0 is just x, and I'll be daggum. Isn't that exactly what we just got, but a heck of a lot easier? So here's the cool thing. If you can't remember this formula, then you can do it the harder way. It's not that hard. It just takes a few minutes. But you have two methods now, so whichever is easiest for you to remember. Now, this one is definitely easier, but if you can't remember that formula, you're good to go. You can do it the other way where you set it equal to 0, factor, and solve. Okay, so let's use the shortcut method for part B. Okay, so we're going to put this in standard form. So we're going to divide everything by 144. 9 goes into 144 16 times, so I get x squared over 16. 16 goes into 144 9 times, so I get minus y squared over 9 equals just 1, okay? So let's figure out what our center is. Well, in this case, our center is 0, 0. A is the square root of 16, which would just be 4. B is the square root of 9, which would be 3. So let's plug all of that into the formula. Y minus k equals plus or minus b over a times x minus h. So we get y minus 0 equals plus or minus 3 over 4 times x minus 0. And you scroll down just a tiny bit. All right. So when I simplify, I just get y equals plus or minus 3/4 x. So the equation for the asymptotes in that previous example, part B, right here would be positive 3/4 x. That's this one right here. And then this one right here would be y equals negative 3/4 x. And I think we had this one as y equals 2x and then y equals negative 2x. So those are the asymptotes, okay? So you can kind of sketch them using this like rectangle method, or you can get the official asymptotes as well now.